This video will show you how to make a simple application that uses the Omniverse and USD libraries which you download with the Connect sample from the Omniverse launcher. The first thing we're going to do is download the Connect sample from the launcher. So here I have the Omniverse launcher. I go to the Exchange, Connectors, Connect sample tabs, and I install it. Now I've already installed it here. And then to actually browse to where the Connect sample is installed, you go to your library, Connectors, Connect sample, go to the menu icon and settings, and then click on this folder, and it will open an Explorer window there. I always like to go to a command prompt here, and I'll give you a quick example of running something on the from the Connect sample. We have this Omni CLI program that's really nice to list and manage files on a Nucleus server. Localhost is the name of my local Omniverse server, and I'm actually going to type this correctly. Here we go, and you can see those are the top level folders on my server. So next what we're going to do is we're going to create a Windows console application. So I'm going to run Visual Studio 2019 and create a new project. It's going to be a console app, C++, and we're going to call it Omni USD Reader. I'll just put it in the temp folder. And this is just a Hello World quick app. Note that by default, it sets it to x86 32-bit platform. We do not want that. We're going to do 64-bit. And always pay attention to what configuration you're running. We'll stick with debug for now. So if I just hit Control F5, it will compile this and run it, and it says Hello World. Okay, now we need to copy the USD and Omniverse client library dependencies into our new simple project. So I'm going to go to my command window, and if we run pre-build, it will actually download everything using our dependency manager. And if I look at what's under the build folder, you can see there's a target depths. That's what I'm really interested in. And we have NVUSD, that's what we want, and the Omni client library. Now these are links that we make. And so to properly copy those links, I'm going to use RoboCopy. It's a nice program that'll do deep copies on those links. So in the I put a forum post out there that describes how to do all this, and I'm just going to be copying and pasting from there. So we're going to copy from our USD folder into our new project, which is on the S drive. And there's a lot of output here, so there's a lot of files, so I'm just going to redirect this to null. It'll go faster that way. Now the USD library has been copied. Now I'm going to grab the Omniverse client library. And when I pasted there, it actually pasted an inline. So let me fix this here. We're going to go to the S drive. Okay. Now, if I look at Omni USD Reader, I'll see I've got my simple project there that says Hello World, and I've got this dependencies folder with our USD and our Omniverse client library. Now we're going to go to the project settings and adjust the linker, compiler, and post-build settings. So if we right-click on the project and go to Properties, you can see we've got General properties. First, we're going to start with the linker. We'll go to all options and then sort them in this way. Make this pretty big so we can find everything at once. Now I'm looking under General. We're looking at additional library directories. Again, these are listed out in the on the forum, and I'm copying and pasting from there. So these are where the program will go looking for these libraries. And that's debug. And then the additional libraries we're going to need, I also have those. Those go to input. Additional dependencies. I'll just tack those on to the beginning and put a semicolon at the end. Apply those changes. Now we're going to go to the C++ compiler options. Again, I'll do all options and sort them this way. And under command line, we want to prevent some excessive warnings that some of the libraries generate. And then the include folders. And that's under general. And then we're going to include some preprocessor defines that are required for boost and TBB. Okay. Those are going to be under preprocessor. There we go. We'll tack those on to the beginning and again put a semicolon in between them. Hit apply. Now we have to have a lot of runtime dependencies in place so that the application can find them for USD and the Omniverse client library. They have a whole plugin system. So I've actually created a batch file that'll help with that. So if I go to post build events, and then importantly, I'm going to go back to my project folder. I'm going to make a new folder called scripts. And we're going to add this copy binary dependencies.bat file. Okay, I'll show you what it does really quickly. What it does is you give it some arguments from the properties, and it will take, it'll copy the runtime dependencies that we need from the USD library and the Omniverse client library into the output path of the executable. So I'm going to go back to properties. I've got that batch file in place where I want it now. And then my command line, again, I'm taking this all from the forum here. I see, there it is, scripts, copy, just like that. I failed to put it on the forum. I'm going to have to edit that, so you get to watch me come up with it all again. So it's scripts, copy, binary, deps.bat, and then we're doing debug, and then put it in the output path. Output path is just a Visual Studio environment variable that says wherever the output executable is. So we're going to apply that. Now we have all the dependencies in place. We have the preprocessor defines, and we have the post-build step set up so that we can compile this project. I'm going to hit F7 to make sure that it compiles properly. So it couldn't find ar.lib. So let's just make sure that we've got this stuff right. So if I go to the linker, the input is ar.lib, and I'm going to go to general, and this is where our stuff needs to be. And what I did is, if you look here, I copied the actual header in dependency directories instead of the library dependency directories. Okay, so if we go, and we can go and look actually and find where that is, so I can just fix it on the fly. So first thing is NVUSD, debug, and I just need the lib folder here. And I bet it's the same thing with the Omni client library. I go to debug, then it's just the debug folder. So lib debug. Yep. I'll hit OK there. And now I'm going to hit F7. And what this does is first it builds correctly, and then it prints 2 lines where it's copying all these runtime dependencies into my output executable folder. And you can see it runs as well. Now that's not very interesting. This program doesn't do any USD things yet. So now I'm going to talk quickly about how this application works and what it does. The first thing is it'll take an Omniverse or a USD stage URL or path argument. It will initialize Omniverse, open a stage and look at some information on it, traverse it, and print out all the node paths it finds, and then destroy the stage object, because sometimes that's something a connector might need to do or an application. And then it shuts down the Omniverse client library. So we have our program here that isn't interesting at all, so I'm just going to remove that. And on the forum, I've provided the actual program, the whole C++ file. I'm just going to copy and paste it in here, and we'll walk through this. So again, this comment describes what it's doing in a little more detail. We're using standard IO stream, and there's the Omniverse client library main header. And again, we're only doing very simple things today, so we're not doing any live updates or anything like that. So all we need is this. And then from the USD libraries, we need stage, prim range, so that we can traverse all the nodes in the all the prim nodes in the stage, and metrics, so we can look at some of the stage properties. First thing we come across is a callback function that simply handles the connection status when you connect to a Nucleus server. I did one of each. I have an actual callback function, and I have a lambda in here. You can use either one. Sometimes it makes more sense to have a separate function. Sometimes the lambda is fine. So the first thing we do is we initialize Omniverse, and you could see this log callback. It's very simple. It just outputs it. And then we set the log level to just info. I don't want this to be too noisy, but we can use debug to see a lot of messages. And then I initialize it with the version. The comment describes why. And then I register my connection status callback, which is good. You want to register this so that when you do get a connection status, if somebody mistypes URL, or if a Nucleus server goes down, or if you lose your network connection, you want to know about it. Now my main program takes one argument, and we basically call start Omniverse, which we just reviewed. We open the stage using a USD stage open. Then we print the up axis, and then we print the stage's meters per unit. We traverse the stage, and then we get rid of the stage, basically close down the stage pointer, the stage object, and then we shut down the client. So let's see if this builds first. I'm going to hit F7. Okay, it built successfully. And I'm going to debug this. Instead of using the command line, I'm just going to put in our argument here is we're going to traverse and dump all the prim nodes in this file on my Nucleus server. So it's Omniverse localhost. This is how the URLs work. And then I have made this stage already with the actual Connect Sample Hello World program. It's users test hello world.usd. I'll just copy that in case we need it later. So again, we're using the debug configuration on 64-bit platform. I'm going to hit Control F5. And we can see what happens here is you do get some info logging from the Omniverse client library. It tells you what version it is and some other information. I'm connecting to my localhost Nucleus server. And then lo and behold, it finds that the stage up axis is Y, the meters per unit. It's in centimeters because that's what the Hello World sample does. And then we go through and we list every prim node path. And we've got a box, a distant light, a dome light, and some materials. This will print out huge stages if you like. It's actually might even be a nice utility just as a very, very low level thing to see if there's something goofy with the stage or what's in the contents of your stage or whatever. I'll close this. And again, we have some options on the stage URL. So you saw me put in the Omniverse localhost sort of Nucleus URL, but you can also do a local disk path. So I'll use the debugging facilities, and I have a local file. I'll copy the path, and it's just on my S drive under Hello World Local. I save that, and then it should be the same exact contents. You now notice it doesn't print anything about my Nucleus server because I'm not connecting to a Nucleus server. I'm just connecting to a local file on disk. The Omniverse client library is a file resolver, and it only will talk to Nucleus if your URL is actually on that server. So this program will work for local USD files as well. Thank you for watching.